All right, so let's look at the problems on the back of those notes. And I've written the formulas for lump sum investment and annuity at the top of the page. We have them for easy reference. So the first problem, Janet's decided to building a college fund for her child. She commits to investing $100 a month and finds an annuity. So we know we're going to be using the annuity formula. There's a 1.72% APR, and we want to know what that value is after 18 years. So when I look at the annuity formula, and V, M, I, and X are my variables. M is the monthly payment or the regular payment, the annuity payment. That's $100 here. I is the APR divided up into whatever equal size chunks we need. So she's paying monthly, so we're going to divide it into 12 chunks. And we have to write that APR as a decimal. X is the number of payments she's making. So she's making monthly payments for 18 years. So she'll be making 18 times 12 payments, which is 216. And we want to know the value. So we're going to take this, plug everything in. Now, we talked about in class how to do this a little more easily with the store function on your calculator. So if you want to learn more about that, just come talk to me. I'll be happy to show you how to do that on your calculator. So I'm going to calculate this, and when I do, the value is going to be $25,296.12. Now, I want you to notice just really quickly before we move on to the next problem that she made 216 payments of $100. So she invested $21,600 of her own money. So the value here, $25,000. So she earned, about $300,500 in interest over the course of the 18 years, which is pretty impressive. So when we look at this bottom problem, we're going to change one number because I messed up when I wrote this. Instead of 12,000, I wanted this first thing to be 120,000. Now, here we have to decide what formula we're going to use first, and then use that formula. So look at the three options. The first option is a lump sum, so we're going to use the lump sum formula for that. And then I would have to find my V, P, I, and X. V is what I'm looking for. P is the initial amount that I invest, which is going to be $120,000. I is that working interest rate, which is the APR, divided up into appropriate size chunks. And then X is going to be the number of payments, which is the number of payments per year times the number of years. So I will plug all that in, and I will do the calculations in just a minute. I want to look at the second option. This is an annuity, so I'm going to use the annuity formula. So I need my V, M, I, and X. V is what I'm looking for. M is my regular payment, which is $3,000. I is my working interest rate, which is the APR, divided into those equal sized chunks. Now this time, since we're making payments quarterly, which is 4 times a year, you're going to divide that by 4. And then X is going to be the number of payments, which again is the number of payments per year times the length of the investment. So when I plug all that in, by the way, that I, that's 0.0031. And then finally, for this last one, it's also an annuity, so we're going to use this formula again. Looking for the value. My regular payment is $1,000. My working interest rate is the APR divided into appropriate chunks. My number of payments is the number of payments per year times the length of investment. So I'm going to plug that in. And again, I'd probably use my store function on the calculator here for this because this is kind of a mess to write out. Oops, I wrote that down wrong. There. Now I'm going to plug these three things into the calculator, return the values so you can see if you're doing it in your calculator right. And I've written the answers up here. Now notice that the lump sum payment gave us the most money at the end, but in order to get that value, you'd have to be able to have $100,000 all at once, which is pretty rare. So if you are going into an annuity, if you look at the two options that we did, the green one, which is the one that's compounded more often, actually ends up earning you more money.